Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. In this video lecture today, I am going to discuss about the critical thinking question discussion on first order logic. So already we know that first order logic, which is nothing but the predicate logic, how we can think about the predicate logic to solve a particular problem, or how we can represent the predicate logic. So this is the course outcome. After the completion of the course, students can discuss appropriate search strategies and knowledge representation techniques to implement inference mechanisms for AI-based problem solving. Now let me come to the problem. We can discuss about this. So here the problem statement says that you are creating an expert system for medical diagnosis that uses the first order logic to represent symptoms and possible diseases. Okay, so we are creating one expert system for medical system, and all the rules and regulations, facts we are creating for the medical systems means including all the symptoms and diseases using the first order logic. Develop a knowledge base that models the relationship between the symptoms and disease using first order predicates, and explain how the system will use this knowledge base to infer the likelihood of a disease given a patient's symptoms. That means what it says, first of all, we'll create one expert system. Already I have discussed what is the meaning of an expert system, which consists of three important components. One is the knowledge base, which stores all the knowledge related to a particular domain, and the knowledge should be acquired from the domain expert. If the expert system is related to the healthcare, then all the doctors, we can gather the knowledge from the renowned doctors to store the knowledge inside the knowledge base in the form of either different techniques are also there, either first order logic or propositional logic, or in the form of semantic network, or in the form of frame. Another component is inference engine, which can infer the output based upon the knowledge which is stored inside the knowledge base. Another one is the user interface through which the user can interact with the expert system. So these are the three components are there, but here the problem statement says that we have to create one expert system for medical diagnosis using first order logic. So we will develop all the knowledge using first order logic by maintaining the relationship between the symptoms and disease. And then we will explain how the knowledge base can infer the likelihood. If the disease is given, then what would be the symptoms? Likelihood of a disease given a patient's symptoms. So suppose symptoms are given to the machine, so machine should understand, and it can give the output what would be the disease. So that is what the question says. So here the problem, let us discuss. So building a medical diagnosis expert system using first order logic, and the goal of the problem is to design the expert system which can diagnose the diseases based upon the symptoms. We use the first order logic for reasoning and will apply the logical inference to suggest possible diseases. So these are the steps are required to build the medical diagnosis expert system using first order logic. The first step is designing the knowledge base. As I discussed, first we have to design the knowledge base with all the knowledges, and then the inference process, how the machine can understand, how it can derive the result. So inference mechanism, one of the mechanism we are using, that is forward chaining. You can use backward chaining also. Like if the patient is like a disease, we know what would be the symptoms we can recognize. If the symptoms are given, what would be the disease we can recognize, either anyway. So that is called as the inference mechanism. Then how the agent's knowledge base gets updated with new knowledge, that is called as updating the knowledge base. And if any uncertain situation happens, uncertain diseases like COVID is a new disease in this world, it came in 2019. So that we can that type of situations can be handled by the system. So that is called as optional enhancement. So the step one is designing the knowledge base. So we will use the first order predicate to model the medical knowledge. So now here few examples I have given. So like this type of examples will be stored using the predicate logic or the propositional logic for the creation of the knowledge base for healthcare expert system. So this is one of the example. If patient has a particular symptom. So how patient has a particular symptom, how we can represent using proposition logic? Patient and symptoms, these are the two propositions. So patient has symptom is the property, patient has symptom. So like this we have to create. Similarly, symptom is associated with a disease. So symptom and disease, these are the two propositions. So symptom indicates disease. So this is the representation of knowledge inside the machine. Directly this English statement, patient has a particular system, a symptom is associated with a disease, we cannot store inside the knowledge base. It requires some mechanism so that the machine can understand. So that mechanism either in the form of logic. So this is the rule we have applied first order predicate logic. Similarly, few examples, more examples, like patient has a disease. So patient and disease, these are the two predicates. So patient has disease is the relation disease. Patient has disease. Same thing here. Disease typically causes symptoms. So disease and symptoms. So disease causes symptoms. Here patient has disease. Patient has disease. So like this we can create the statements using first order predicate logic. So all these statements will be created and it will be stored inside the knowledge base for further exploration. Now step 2 is inference process, means forward mechanism will be applied. So for example, here we'll see the goal of the inference mechanism is how the system or the expert system can infer the disease based upon the symptoms. We will give some symptoms like a person is having fever and cold. So the machine should understand fever and cold means it can infer the result the patient is having flu. So this type of inference mechanism we will apply. For example, here suppose the name of the patient is John, and John, what are the symptoms for the John? John has symptom fever. Okay, directly I'm telling because already I have mentioned the statement, English statements in the form of predicate logic, first order predicate logic. So John has symptom fever. John has symptom cough. Okay, so these are the symptoms it is showing. Now symptoms, after giving the symptoms to the machine will indicate something, means the machine will try to match the rules which are already stored inside the knowledge base. Suppose already we have stored the knowledge like if a person is having fever, then it may be flu. If a person is having cold, it may be flu. If a person is having both fever and cold, it may be flu. Or if a person is having fever, cold and cough, it may be flu. So here the system logical inference that fever indicates flu and cough also indicates flu. So what is the matching? So to find out these inference answers or the diseases, some matching rules are used. So these matching rules is done. This is called as inference mechanism. So what is the matching rule? John has symptom fever. This symptom is given to the machine. John has symptom cough. This symptom is also given to the machine. Then fever indicates flu. Already we have stored as a rule. Even cough indicates flu. Already we have stored inside the machine. Then from these four, what the machine will understand? Machine will understand that John has disease flu. Okay, so this is the way John derives the what type of problem he is suffering. Okay, so that is called as inference mechanism, and here the inference mechanism is forward chaining. So final decision will be given by the machine as John has flu. I mean, it suggests the patient is likely has flu. Now, step 3 is updating the knowledge base. When more symptoms are added, it's not like flu, some other symptoms will come. Like John has symptom fatigue is also there. Then in that case, this type of statements we have not stored inside the knowledge base. So, but machine, once the symptom is given to the machine will try to match the existing rule. Check if it matches the additional disease or strengthens the inference for existing one. If it matches, okay, it will derive the conclusion based upon the matching rules. If it is not there, then this rule will be added inside the knowledge base and it will try to find out, try to correlate with flu or some other diseases. Then if the John is having fatigue, fever, cough, cold, then what could be the conditions, right? So any new things comes into the picture, it will be added inside the knowledge base. Now the step 4 is handling uncertainty or optional enhancement. First order logic, as it is a deterministic, because every output of every action can be determined in advance. So to handle likelihoods, you can extend with like certainty factor or probabilistic logic. Sometimes the predicate logic and first order logic may not work out. It may not find the correct answer. So in that case, to handle the uncertain situation, we used to configure the knowledge base with certainty factor, or we can provide the rules in the form of Bayesian network, or which is called as the probabilistic logic. But why? Because in pure first order logic, you use the count of matching symptoms as a proxy for likelihood. If the rules are like, what is the meaning of this statement? If the symptom is matching with the rule, then only it can derive the result. Otherwise, it cannot, it may give the wrong result also. So to avoid that problem, we can go for this Bayesian network or certainty factor. And in your pure first order predicate logic, it more matching symptoms means more stronger confidence. So, but still some drawback is there in the first order logic. It may not find the correct answer, then we'll go for the probabilistic one. So this is all about for this particular video. I hope you might have understood and enjoyed how to create the expert system and how to design all the rules, how to define all the rules using the first order logic or the predicate logic, and how the inference mechanism can be configured inside the knowledge base, for the expert system, and how it can update its knowledge base based upon the new inputs. So all these things I have covered. So, and for the preparation of this video, I refer Sarascosic for artificial intelligence, and for your reference, I kept the picture of the book on the screen. I hope you might have enjoyed. So till then, take care. Thank you. Bye bye.
Like, share and subscribe. Hit the bell icon for more updates.